Okay, good afternoon. So we will be looking at two selected years of rainfall. Selected one drought, very famous drought, and one flood year, very frequently nowadays, but it occurred in 1994 when 2% excess of monsoon. So we will just repeat the rainfall patterns and the government that drove them. This is not working actually. Like mouse. No. Okay, so as the outlook, we will just look into the rainfall patterns in the year 2002 and 1994, and we will also try to understand the signals that govern the rainfall patterns, if explainable. And we will then go to the conclusion of this small talk. So just to give an overview, there are plenty of studies on the intra-seasonal oscillations that control the Indian summer monsoon rainfall. So the first reference talks about the effect of the intra-seasonal oscillations on seasonal as well as the inter-annual variability of the Indian summer monsoon. In that paper, the authors basically found that the structures of the intra-seasonal oscillations in the active phase is very much matching with the active phase monsoon structure. So that's how they correlated and anti-correlated those structures. The second paper talks about they found two modes. One is the usual 10 to 20 days high frequency mode, another is the 30 to 60 days low frequency modes, and how their interactions govern the summer monsoon rainfall in this region. And there was a case study on the third paper. In the third paper, they talked about the role of the inter-seasonal oscillations for the 2009 monsoon drought. So that the drought is very much attributed to the El Nino Southern Oscillation or El Nino phenomena, but they showed that the drought was actually driven by the inter-seasonal oscillations, and they explained in that evidence. Specifically, they brought the notion of the planetary scale equatorial Rossby waves that interacted with the negative phases of the low frequency and the high frequency oscillations, and that led to prolonged phases of less rainfall or drought-like situation. The fourth paper again talked about the propagation mechanism of the inter-seasonal oscillations and the pattern over the monsoon region. And the last paper has again discussed the case study of the rainfall 2002, what led to the drought, and what is the role of the inter-seasonal oscillations. However, they also invoked the sea surface temperature as we connect with the kind of IOV with the rainfall increase or decrease in these regions. So just we can look at the features of the June to September rainfall in these 2 years. So the 2002 was a remarkably strong drought year with minus 90% of the long-term average, and some characteristics of the progress of the monsoon. The progress of the monsoon was very sluggish. It faced two hiatus and it proceeded towards the end of the boundary of the country on 15th of August. And so much of the north and northwestern India was not under the influence of monsoon for a prolonged time in June and July. And there was no depression or stronger systems, I mean deep depression or cyclone, this type of systems, and 10 low pressure areas formed in this season. So we'll talk about a bit about the number of low pressure and rainfall. So that's why I just and coming to the 1994, it was a flood year with 12% more than the average rainfall, and the monsoon covered the Indian country earlier, and there were 40 low pressure systems and 1 depression in this season. Now, proceeding to our analysis, we used the data of ERA 5 reanalysis data, for rainfall and winds, though I must agree that that is not a very good proxy for the rainfall, especially the reanalysis data, but that's what we used. And for the outward longer radiation, we used the data from the NOAA, and as we looked at the large scale oscillations, so we just took the daily average that worked appreciably well in these regions. And we filtered those data. We categorized into three systems in the interseasonal scales. So one was the synoptic scale, which has a time period of less than 10 days, like the monsoon low pressure, depression, shear zone, the cyclonic circulations, etc. And higher frequency oscillations, which mainly is attributed towards the equatorial Rossby wave or similar kind of oscillations with time period of 10 to 25 days. And lower frequency oscillations, which are famously attributed to the boreal summer interseasonal oscillation, BSISO or WISO, 25 to 70 days. So this type of, these three categorization we have done. And we looked into the core monsoon region of 17.5 to 22.5 and 75 east to 82.5 east. That is the area of our study. And we looked into the peak dates of the rainfall. Now coming to the rainfall pictures of 2002 and 1994. In 2002, there was very less rainfall. You can see the anomaly here. It is mostly it mostly grabbed the entire India, and though however we got some excess rainfall in the northeast, but mostly in the core monsoon zone and in the Indian region, it was a severe drought-like situation. And in 1994, on contrary, we had excess rainfall in the core monsoon region, but we had less rainfall, of course, in the northeastern India. But all over India got a 12% higher rainfall. Yes. The departure was calculated from which peak? So departure was calculated from the climatological peak. In our data, we took the average of 1990 to 2010, that 21 years of data. Okay, but yeah, I mean, of course, I could have taken longer time scale, longer time series. And so we will now focus on this box, as we mentioned, that is defined for this case, the core monsoon zone, and we will look into the time series of this. So here, time series means the average of the rainfall in this box. So it is the case for 2002. So this is again departure from the climatology. And you can see that there are some peaks, but on an average, there are more downward values or less values than zero compared to the peaks. So if we just sum it all, it will give less rainfall. So minus 19% rainfall. And the climatology is shown here. Here we have shown the 25 to 70 days oscillation. Here 10 to 25 days. Here the synoptic scale oscillations. And here anything less than 70 days. So it can be seen as a summation over this, and these three oscillations. So this is pretty much mimicking the rainfall. And if we look into the peaks, we can see that the peaks of those rainfall days can be closely related to the peaks of these oscillations. Now coming to the particular case. So this is the 25 to 70 days low frequency oscillations. So here one peak occurred at the end of June. Second peak occurred mid-August, and the last peak was out of the monsoon range that occurred in October. So that was a very strong peak, and that attributed some rainfall to this region. But sadly, the monsoon did not cover all the regions of India at that point of time. That was well within the monsoon season, but this oscillation was not that supported by the 10 to 25 days oscillation in this case. And later we will see plenty of synoptic scale systems there, but we will see that even if there are a lot of synoptic scale systems, unless there is the support of the background, we won't get heavy rain or sufficient rain in this region. So attributing the drought to the interseasonal oscillations, the first peak was prominent, but the monsoon did not cover the whole country. The second peak somehow contributed to the rainfall, and the third peak was strong, but it was out of the range for the June, July, August, September. So overall, we had a very less amount of rainfall in the year 2002. Coming to the 1994, we had three strong peaks in the June, July, August, September for the low frequency oscillations. Plenty of 6 to 7 quasi-biweekly or let's say 25 days oscillations were also present, and support of the synoptic scale systems were also there. Overall, if you follow this graph, you will see that the locus of the point is mostly situated towards the upper part of the ordinate compared to the lower part. So you will see more positive values compared to the negative values. Overall, it gave rise to 12% of increase. And also the peaks will overlap with the peak rainfall days in this case. So we got good amount of rainfall in the year of 1994. Here is just
a minute. Go back. So if we average the rainfall for this filtered rainfall, right, along the season,
it will give zero.
It will give zero. Then how do you say this contradicts?
Yeah, so there is a physical reason for that because the rainfall physically has a limit of zero. So lower limit of zero. So the lower limit of rainfall is zero, but there is no upper limit of rainfall. So if there is in-phase relation between these oscillations, that will give rise to very heavy amount of rainfall. But if there is out-of-phase relation or negative relation, at most, at the worst, it can give zero rainfall for the few days. So that is the logic that we think we can proceed with. So in-phase relation will give you very good amount of rainfall, but out-of-phase, at worst, it can go to zero, not below that. It cannot go to -5 or -6 millimeters per day. That is
okay. But it's a mathematical reasoning.
Yes.
So we can talk about this, but then that your answer is not consistent with the it does not concern the mean rainfall. Because finally, if you add all,
right.
You get the total.
Yeah, addition of this will give
the total.
Sure.
So therefore, it does not. It's okay. I understand.
So the glacial inflows will be heavier, but the rainfall inflows will not be that scarce. That is the main logic behind this. So now we just look into the number of low pressure systems with percentage departure of rainfall. Just a plot to show that the number of low pressure systems really don't affect. There is no correlation or any linear relation between the number of low pressure systems and percentage departure of rainfall. The data is taken from 1991 to 2025, that is 35 years. Maybe greater sampling might lead to some consistent result, but taking into account this data, we didn't see a correlation between the departure of rainfall with depression or low pressure systems. Now we will just look into the pattern of the low frequency oscillations in 2002. So we have selected 4 peak rainfall days and we have tried to attribute the rainfall days with low frequency and high frequency oscillations. In the June month, it was a very strong low frequency oscillation and it gave rise to good rainfall, but the monsoon did not cover this region for this particular year. In July, it did not support the rainfall. In August, 22nd August, which was another peak rainfall day, it was kind of neutral. In September, this oscillation actually would propagate northward over the next few days, but it mildly supported the rainfall, but it was out of the range for June, July, August, September. So it could not account for the drought situation or could not better the drought situation. And there's the high frequency oscillations, which had a good support in the June, 23rd June. In July, also it gave good support. In August, high support, but in October again it supported, but overall it was not fruitful. So if we just sum these two oscillations, we will see that for the June month we got good rainfall. This is basically OLR, it is not rainfall. So lower OLR values would indicate deep convection and therefore limited to higher rainfall. And this August was also not very worthy. And October was strong, but it is out of the monsoon period. So overall, we didn't get good amount of rainfall. So the June was, here's a picture for the rainfall. So in June, we got good amount of rainfall, but apart from that, we got very rare rainfall. That rainfall was mainly due to synoptic scale systems. Coming to the year in 1994, we got support for basically all of these oscillations are situated within the June to the September period. So it was supported in June, neutral in July, negatively supported in or opposed in August, and very highly supported in September. For the high frequency oscillations also, we can see that in June, it basically supported the convection or rainfall. In July, it mildly supported. In August, it was opposing, and in September, it opposed in the eastward side of the monsoon zone, but supported in the westward side. So overall, if we just sum those interseasonal oscillations, we got good amount of contributions in June, even in July, and also in September, but August was driven by the synoptical system. But overall, we got very good amount of rainfall in this year, leading to the flood-like situation. This is just a plot for the rainfall. So there was no strong oscillation. So this was the signature of the synoptic scale system. And in all other cases, the synoptic scale system as well as the oscillations were present. So it is synoptic scale system. All the peaks are associated with synoptic scale systems, but if an oscillation is present and it is in the positive phase, it will enhance the rainfall rapidly. Whereas if the oscillation is a synoptic scale system is present, but the oscillation is not favoring the phase of the synoptic scale system, then it will not give us good rainfall. But there is also a physical barrier of zero, which we cannot cross. So that is the reason due to which association between these interseasonal oscillations with low pressure systems or synoptical systems would give a good amount of rainfall and reduce the possibility of drought or bad rainfall. So coming to the limitations, we can of course go to the limitations first. So we ignore the interannual signal, El Nino type of signal, or any larger scale system, which of course changes the basic state of the mean and therefore modulates the signature of the rainfall in this region. However, we ignored that part and tried to explain wholly using these interseasonal oscillations. And a limitation for our current computation or current physical understanding is that we don't know the mechanism exactly. So we were not sure about what would exactly be the period of the 25 to 70 days oscillation. Would it be 30 days? Would it be 40 days? Would it be 50 days? We don't know. Same goes for the 10 to 25 days oscillation. So whether we can predict the overlap between these two oscillations or we can predict the overlap between synoptic scale systems and these oscillations are not very well understood till date. And the formalism that we have proposed that requires a stable basic state, because if the base state is varying, then all the calculations will be modified. So the base state will be, of course, attributed to the interannual, maybe interdecadal variable. And yeah, we have just taken 2 years of study. So maybe a composite for several years or taking more extreme case studies based on that can lead to a better physical understanding of these systems. And just for the summary, So the monsoon signal, as Professor mentioned, that it can be decomposed in those seasonal, low frequency, high frequency, and low pressure systems. So the sub-seasonal and the synoptic scale systems would sum up to a very small number, which is ideally zero. But the interactions would be imprinted on the seasonal mean. So in the seasonal mean, we will get JJS mean rainfall, let's say 780 millimeter or 800 millimeter or something like that. But that will be modulated by those low frequency and the high frequency oscillations interacted with the synoptic scale systems for the low pressure systems. But we have also seen that the low pressure system, the number of low pressure systems or the intensities of low pressure systems will not play major role in controlling the rainfall. Just I mentioned that it has a lower bound of zero, but no upper bound. So the relative phase differences, phase relations between the oscillations would control the total rainfall. And so from that, we come to the conclusion that drought is likely when low frequency oscillation is not strong in established monsoon states. So after the monsoon has reached all over the India, of course, we cannot say it delays if it is delayed, if there's hiatus, we cannot say that. But taking into account the fact that it has been established, what would happen? And the transient rain would, of course, follow the reverse condition or the significant overlap, positive overlap between the low frequency and the high frequency oscillation. And without the support from the larger scale systems, the synoptic scale systems can contribute, but not totally or not much. So we will put as a passive contribution. Yeah, so that was the overall topic. Thank you for your kind attention.
Thanks, Shubhrangshu, for giving a talk at short notice. Anupam Java supposed to talk today. So it's Bertin, thank you. I want to ask, this approach, people tried intrinsic mode function. Have you seen any paper on that?
Intrinsic mode function.
That will resolve all the time scales in a rational way. People have done the interannual, but inter-scale I've not seen.
Okay.
Somebody must have done it because once the technique came, everybody applied it to everything.
Okay.
And just look it up. It may
Yeah.
throw a very different light.
Sure. The only problem is that, let's say the peak is at some season is present in the maybe 35 days. On some other season, the peak might be present in maybe 55 days. So exactly getting the mechanisms beforehand, before the season is.
Yeah, I am aware of the problem. The beginning and the end is a bit of a problem. But some people have taken a whole year,
Okay.
Jan to December. Okay, we are interested only in this part. We use the whole year. Most of the rainfall anyway is JJS. So I think somebody has done it because when it came about 20 years back, it was very popular. It was applied to everything. And the reason why I like MF is that you don't impose anything on it. You let the tablet tell you what are the modes.
Right.
Only weakness is the endpoints. Yeah, that's a big point there.
Sure.
Okay.
Thank you for
But
this.
I have a comment that we have done a lot of work with Nirup on this. I'm sure you have seen it in the monthly review paper, right? That is that how the low frequency and high frequency go together to give high rainfall or rainfall over Central India. If you have not seen, maybe you can see like in 2007 we have looked at South 17.
Sure.
But then that's only a comment. But I have a question to you. See, this mathematical or this is, I mean, what we are all this filtering, we all do. Right? But I'm saying that this is the driven by mathematics or driven by
Yes,
physics.
I mean, driven by mathematics, but in the mathematics, we have a constraint that the lowest value of rainfall can go is 0. So that is the thing. Mathematics, but the physical notion is there that the lowest value is 0. So if there is some moisture accumulation due to this positive alignment of these phases, the rainfall, the lowest rainfall it can go is 0. The highest it has no such bound. That's it. Yeah, it is not very rigorous. It is heuristic, but
Yeah, I have one more I can do. Again, based on what Nirupam did with the NSSC, we found that at the stronger having gravity is as compared to the
right.
excess years. So you are saying NSSC is not strong. I'm not sure what in what sense you are saying that is not strong because he's here saying there's more conflict during development. And then even Ritesh should also seen the same thing when it was NSSC analysis for that.
Okay.
So maybe you should. I don't know if
Yeah, we just try to mention that if the low frequency is present and along with that a synoptic scale is present, then the overall effect will be enhanced. But if it is the opposite, it will not be subdued that much because 0 is the lower bound.
Yes, maybe okay, your style of analysis might be different.
Yeah, that is, I think, yes.
Certainly, LS is more prominent to be.
Yes, I think, yeah.
I have only kind of comment on.
Sure. Thank you for. Yeah, any other questions?
Anybody else? Okay, thank you. Before I start, let me make an interesting analogy. This year, right in the month of March, you know, it was a drought here. So it confirmed in May. Every model is confirmed it. Okay, it's not going to change. The only issue of discussion this year is how efficient the monsoon will be. Will it be 8%, 10%, or 20%? Okay. So this is because this year it was very clearly that the large factor, El Nino and all the other SST factor is governing the final single rainfall. Okay. We talk every week about synoptic systems. They are not controlling what's going to happen. They are slave to the large scale structure. So I want to give you an analogy. It's a crazy analogy. It was cricket. Okay. All of it for T20. I don't get the game. They'll get because it's a very short game, but it has following future. We have the power play of 6 overs. That is the June onset rainfall. We have the 7th to 15th. That is the July, August, and then we have the delta overs September. Okay. Now, when you watch a match, there are ups and downs. We start very well, then we go down. But finally, all of you know when you watch any match between two teams that are not very close, what the difference will be. I'll give you an example. Afghanistan team I really admire. They're playing under adverse conditions. But whenever they play India, we know India is going to win by and large. Okay. So synoptic movement every 5 hours doesn't mean anything. Ultimate result is known because the basic talent in the Indian team and that in the Afghanistan team is quite far apart. But the match may have few exciting moments. So synoptic thing is like that. We go through all this. We had a very heavy rainfall event, then there's a drought. But we all know at the end this year is going to be a drought. So this point I want to make because very often many people try to argue the seasonal mean in terms of synoptic. I'm totally opposed to it. My opinion is that the seasonal mean rainfall is controlled by totally different factors. What's happening within the season is forced by the conditions imposed from the outside. In one is my belief in the energy budget, the other is in the large scale energy pattern. As a matter of fact, at the end of this monsoon, we'll clearly see whether the forecast made by Suman Nigam, who uses only SST. Okay, let's see how close it is. He is very close, I would say he has got the basic understanding, not understanding, basic ability to predict rainfall over India based only on SST, and all the other factors, it doesn't matter. Okay. So today you clearly see that right? That the monsoon is very weak over India. There is some action here in the Bay of Bengal, but that's it. Now, if you look at the situation in August, we are 11% below normal, and which means that our hope to make up June is pretty much gone. So July was good, 1% above normal. But the key point I want to notice in July, which is very peculiar, is that centrality of 30% above normal, and the other two big regions were almost equal to opposite below normal. Okay. Now, when you come to August, everything is, even the second India is doing well. It's close to normal, but all the others are below normal. Now, we look at the cumulative rainfall pattern compared to what we saw a month ago. Things are a little better. There are only a few divisions which are below normal, and these are, of course, except Orissa and Maharashtra and Gujarat. Okay, as I want to show you an interesting result from people who look at break days. Okay, why I show this is normally August has more break days than July. Okay, August is typically a month where breaks are very common, and I'll give a very simple example. On 15th of August, which is the Independence Day, the Prime Minister gives a talk. In the last 79 years, there are very few there was rainfall in Delhi. So August, there is a minimum around 15th August. That is clearly shown a number of break days. Can add it all up. They are doing it 20 wide. I would actually add it. You can see in this decade, it was as high as 66, okay? And there was one decade, this one, which also was good. There were only 22 break days. All of them in the last week of August. Okay? But by and large, you can see that August, but this year we are lucky. We did not have too many breaks so far, but still, we are only 12 days into August. We don't know what will happen. Now, if you look at the All India rainfall, you clearly see that for June and for July, slightly weak August recovered. And the question is what will happen now. But if you look at this picture for the core monsoon zone, I would say already the warning is clear that we are already in the decay phase in the climatology. So chances are very low that somehow it will make up rapidly in this season, okay? Unless there's an IOD or something. Otherwise, we are going along this line under normal conditions. So we can never make up the 10% difference we have. Okay? Now I want to compare in east, northeast, and south. Okay. Note the interesting thing. We had a very low rainfall in the middle of July, and look at what happened in the east. Okay. They are pretty much out of phase, east. And the second point I want to point out is, in spite of all the floods in Assam this year, the deficit is very large. Okay. So this is very surprising. There are so many floods, but that region has deficient rainfall. But in any 1 week, flood is a very short event. Look at the last week data. Okay, look at Assam. Very interesting. Look at all the excess. This is normal. This is all excess. Dark blue. Okay, all these excess rainfall would have caused flood all over the place, where it never rained, because of the terrain of Assam. If it rains upstream, downstream, same thing in Bihar. Bihar suffers heavily because not it rains heavily, then it rains in Nepal, and all the rain comes into Bihar. So this is a situation which is very unusual because of the terrain here. Now let's look at how good the prediction was for last week. All of them, you can see that the country as a whole, the deposit was more, forecast was 0. And this is quite bad. South India had a lot of rainfall, but prediction was wrong. Same here, Northwest India also, it was so this I'm showing you because this is initial condition 1 day before the prediction. So we think normally it's going to be very good, right? It's not good. So obviously, we have a long way to go in getting the regional rainfall correctly. This you may argue is not bad, but I would say when you see all this added up, this is based on these two are just trying to give you that. Let's look at the pattern of yesterday's rainfall, this morning's forecast. You can see that this trough rainfall contributed to this structure here, and rest of India had nothing. Okay. El Nino is carrying on very beyond 2.2, and whatever data I have, this is relative Nino. Remember that. You had some more to get actual Nino. There has been no August the last 3 years when it was so high. No time. Okay. And this is going to get worse in September. It's going to go close to 380. See the steepness of the curve. So in the period from March to now, it has gone up by 1.8 to 3 degrees in 5 months. So 0.6 degrees per month. So it's going to increase 3 degrees by September 9th. So again, you see that the Vichuna forecast, the trend was right, number was wrong. It correctly showed a decline in rainfall as we go to the middle of August. Observations were perfect, but the numbers are wrong by there's a clear bias in the forecast. This is the forecast for the next 1 week. Slightly good news, it is going to recover to close to normal. And that will make August, be as good as July, but will not be 10% emission. But again, GFS tends to underpredict rainfall. Okay? I still don't know why you have dry bias while Mithuna has a wet bias. This is the forecast for the next week. Again, it is 6 millimeters per day, while other one is showing more like 7 to 8. Let's go back to EWF. This is what is a break concern now. It's going well outside the normal range, okay, in September. And if this happens, this year the rainfall will not go above 800. I can guarantee that. Okay? No chance. Unless I don't appear. I'll talk about why it's difficult to predict that. Okay, now to understand IOD, you must understand what's happening in Sumatra. Okay? Sumatra is the place where the winds cause upwelling. Okay? And this coalescence appears and warm already there in the sky. So that will show you. So the point is that the this scientific the highest scientific occurs in October. In August and September, it's coming up, but it's not yet reaching the equator. Okay. So some years come a little earlier than it becomes a positive IOD. So that's the problem with IOD, that it appears late in the season, September, October, and if it's slightly off, it will not help Indian monsoon. On the other hand, both Indonesia and Australia, IOD is very useful. But my IOD is used repeatedly by Australia and Indonesia forecast the next 3 months, that is October, November, December, January. Very good forecast. But we are unlucky, our monsoon ends in September. Now here is a nice, they took the path along this trajectory, okay, along the coast of Sumatra, and looked at the month of September, October, that cold thing appears. Okay? This is around this is around this path. So only 2 years will extend up to see that compared to 0.4, which is this one, and IOD this one, the amplitude of IOD is much smaller than 3.4. So the signal is already somewhat weak. That's why forecasting is very tough. Because it rarely crosses 0.5, except 2 years. This is, of course, 98 and 62, 61, 62. So 2 years, otherwise it's all around 0.5. So I can see the forecasting is much more difficult. Now, I want to show it because I have always felt that one must compare the Indonesian rainfall with Indian rainfall, because when you look at the ENSO pattern, the highest signal is over Indonesia, not India. Every time there is an El Nino, that region is always below normal. So I always wondered why people are not comparing it with India. There's one problem. Indonesia is near the equator. Their monsoon season starts in October, not JJAS. You look at JJ, the rainfall in Indonesia is very low. And compared to India, they do not have enough spatial data. First. Secondly, it is a nation with lots of islands, a lot of orography. So even if I think we have 50 stations, it's not enough. Because most of the rainfall is orography, even though in direction. So I'm not seeing any good paper, somebody can correct me, or rainfall like ISMR and commenting on its connection to other regions. Okay. So in this paper, which is a strange journal I've seen here, I think it's based on complex proceedings, I think. What is shown very interesting. When you have positive IOD in El Nino, okay, which for India is good, it's bad for Indonesia. Indonesia has a very severe drought. In not just about it, but so okay. So they don't want positive IOD. It affects their result. Then you look at La Nina and negative IOD, they are very happy. They get very good rainfall. Okay. In other years, sort of uneven. So these are the two extreme things in Indonesia. When it's El Nino and positive IOD, they are in deep trouble. Even La Nina and negative IOD, they are very good. Okay. But all these are September, October, November, it is no use to us. Okay. So I don't know. I think there comes out a one word June, July, August. I don't know what is the error point. Okay. Now the other point they point out in this paper is this international through flow plays a role. Difference between these two. Okay. So they are saying this is of course much warmer in the Indian Ocean. So when there's a flow through that, it affects the SST locally, and they claim that affects the water vapor, and depending on the direction affects the rainfall in Indonesia. Okay. This is the complexity of the pattern in Indonesia, the oceanic circulation. Okay. So that's the reason I think Indonesia is not content to analyze. You can see the number of small islands. There are hundreds of them. The equator, but then JJ rainfall is very low there. Okay. Now let's look at the correlation melting point for again for September, October, November. You can see that it is very interesting. It is two-sided. It is correlation positive here, negative here. So 120 to 150 it is negative, and that 120 is positive. But again, September, October, November, not JJS. Now, again, I want to remind you, this is the rainfall pattern in Indonesia, two stations. You can see that the peak rainfall occurs February, and when we're interested, the rainfall is around 20 millimeters. So obviously that doesn't no use to us. Too small, other one is too high, we cannot judge it. And another picture here showing the low in July, okay, and the high standard deviation. Okay, so there are people predicting GMI for SO1, but again, no interest to me. So this is a problem. This is a machine learning method. It's quite impressive. They're getting all the patterns correctly. This is observation flag. Rest are leaves out so many months. And so September, November, average the most interesting part about the Pacific Ocean is the strong longitudinal gradient in the Pacific. Okay, so the main point is that the convergence here is convergence here is gone. So closely, what is happening here? What convergence? So this problem is out. This region. So what happens here would have an impact on both China and India. And how convergence in this region has impact on Asia. That's worth looking at. So this is a point you're making. When does it contribute to convergence in East Pacific? Zone gradient are contributed to the West Pacific. And they have an impact on all the other regions. Now let's look at CFS forecast for the next few weeks. Quite bad. So this system, what happened just now is continuous some rainfall, low some rainfall, just a bit here back. This is the next peak. This is 20 to 27. It's getting worse. This is getting weaker. This is getting stronger. Okay. So this is first week of September, completely India covered. Okay. Now this is a very interesting. I think there is some clear large scale thing which is controlling it. Why September is going to be not below normal, well below normal. That's what it looks like. Look at the anomalies here. I believe this is millimeters. Yeah. So high as, I don't know how, as high as, yeah, 60 millimeter. That looks very large. Okay. For a weekly picture, it is extremely large. Now let's look at ECMWF. We have done this all along. And it's clearly the next week, there is a clear large scale impact of rainfall in India as well as all these regions all the way there. Okay. And there's a lot of rainfall in China. There's right now it's a typhoon, but that may not that may be there in the next week. Then you see the week after that, still it continues. The large scale descent. We go on to 1st September again. So you can see that both CFS and India were completely consistent. There's no disagreement because there is some large scale factor which is controlling both. Second week of September, still same. Okay. Okay. Third week of September, still same. So clearly, September is going to be although we don't have a break in September because that is the retreat of the monsoon, but it's going to have pretty low rainfall. Okay. Average should be around 150, but it may be 80 or 90 or something like that. Now let's look at prediction from multi-model CFS, Indian prediction. Same. September is looking extremely bad. The probability of below normal is very high. Okay. Now let's look at the reason why. Now I just plotted the September rainfall anomaly for all Illinois years. Okay. In all the years, September is below normal except 2023. Anybody can tell me why? Huh? That's the IOD. Okay. IOD is the only saving grace of September. If it's not there, as a matter of fact, 97 had also IOD, but it didn't have too much impact on September rainfall. Okay. So to me, this clearly shows that this is a phenomenon which is related to El Nino, and this El Nino is very strong and nothing to do about it. This is, and if this is true, I believe that the forecast of IMD will be wrong. They'll be right that it will be below normal, but the quantitative prediction will be not correct. Okay. It's not easy. Predicting drought is very hard. I want to compare to August. August, same El Nino years. August, you can see it's equal. Half years, how they are top. Same thing with July. So only September has a strong link to El Nino. Still, I looked at it, but I've not found a clear answer why El Nino impacts September much more than July and August, or even June. Yeah, I want to end with an interesting statement. I don't know much about the stock market. They started a new thing called Rain Mumbai. The contract allows you to bet on the rainfall events in Mumbai through the season. Now, all of you know AI, please get it to make some money. I don't know what it is. Just what is the quarter? It is daily or monthly. And I don't know what it is for insurance companies wanting to know. So what you want to know is what So cricket is a game I like, but it's the only game influenced by weather and climate. No other game is as much influenced. Weather being rain or cold, there's no game. If there is a rain and test match, it affects the second week. All kinds of things happen. Very interesting. Okay. Now that's why in India we never schedule a test match in the monsoon season. Never. The last 70 years I followed. June to September, no cricket in India. Test match. Cricket cannot be the other games. So at the end of the week, we have a test match in Sri Lanka. Can you tell me why?
Test matches scheduled in one side of the only in one side of the country has test matches during this time of the year. Like they have grounds in multiple both the coast, east and west. I forgot. Like one coast is for the monsoon season, the other is for the other.
Yeah, I mean, Sri Lanka has an interesting seasonal variation, but the most important thing is because Sri Lanka is the equator. So the climatology is very clear. Minimum is in August. Other than, of course, winter. So they are hoping that it's going to rain in India in August, and it won't rain in this one. I think they are wrong. They didn't know what happened at match because there's a very India that forecast for next week. So stop here. Okay.
The